So this is a course I'm taking. I'm teaching Introduction to Data Science, and this is the outline we have for today. What is data science? What is not data science? Data science versus machine learning. We're going to have some data science examples, like some practical examples we can all relate to, and then we'll talk about the skill sets of a data scientist or scientists, yes. And then we'll also talk about the data science pipeline. So straight into what data science is. And so data science is actually a multidisciplinary approach that combines principles and practices from the fields of mathematics, statistics, AI, and computer engineering to analyze large amounts of data. So initially, I happened to have a statistics with computer science background. And then some years ago, like say some 5 years ago, there was nothing like data science. We knew about the software engineers, we knew about the statisticians and all that. But data is increasing. I mean, the amount of data that has increased over the past 2 years alone is like over a terabyte. A lot of data. We go on WhatsApp, we post our pictures, we comment on others, we have a cloud that we put our stuffs there. You go on Instagram, same. You go on LinkedIn, same. So everybody is getting, because everyone wants to build a social media presence. So everybody has at least maybe 3 to 4 different accounts, and the number of people in the world keeps increasing. And so data is like everywhere. Even if you go on the link on the internet, you click, you search, you click, every click you make, is data. So over the years, data is increasingly growing, and we've realized that mathematics alone cannot do it. Statistics alone cannot do it. Even computer science alone cannot do it. Even though they can do the analysis, but it might not be, how do I put it? We can do, because initially we've been doing the traditional statistics, we do our data cleaning and all that, but they've realized that it's not enough. So because the data is actually growing, they want to borrow idea from different fields. So they want to borrow a math idea, borrow statistics idea, borrow something small from the computer science, borrow a bit from artificial intelligence, and then all together they come and then they're able to make like better insights and better meanings into data. So that is how come data science. If you look at the diagram, you see that we have computer science, math, and we have the domain knowledge. So data science happens to be in the middle. You need a bit of math, it picks more from math stats, it picks more from computer science, it picks more from the business knowledge. And when I say domain, I mean either maybe you're someone in the health domain, or you're someone, maybe you have a great background, or maybe you have finance background, you have accounting background. So that's the domain. And the math stats is just the foundation. We have the computer science who also do with more of the coding. So intersection of the computer science and math, you see the machine learning at the top there. You have a domain knowledge in a field, and you apply some computer science, you're a software developer. Then if you have the math stat background and the domain knowledge, then maybe you're a traditional researcher. So I would say maybe I used to be a traditional researcher, but I want to actually combine all these fields to be able to make better predictions. So data science is actually lying in the middle of everything. And so I believe that this definition will make it clear to you what actually data science is. What is not data science? So as I mentioned earlier, data science is not just statistics. Of course, you need statistics to be able to be a data scientist, yes, but statistics is not enough. So I'll use my life to make it more interesting so you can all relate. So I'll say for the past years, I've been doing statistics, even I have an MPhil in statistics. But I realized that even though I have the statistics background, it's more of like just the research, the theses and all that. Even you do the theses and you're not even able to deploy it, and just like the book knowledge. So I realized that no, I needed something like really practical. So I decided to upskill, to specialize in data science and analytics. So I actually took some short courses to actually put me, and because I had a computer science background, it was a bit easy for me. So data science is not just statistics. If you have statistics background, it doesn't necessarily mean you are a data scientist. No, because you need a lot of skills, and statistics is just one of it. So let's keep that clear. Also, data science is not machine learning. It's actually not machine learning. Machine learning is just like one of the skills you need as a data scientist. So data science is actually like very, very broad. Machine learning is just a portion of it. And so maybe if you want to be a machine learning engineer, then your focus will only be on like building models and deploying models and all that. But as a data scientist, machine learning is just like a small fraction of it. So if you have an idea or you know how to build models and deploy them, it doesn't necessarily make you a data scientist. As a data scientist, you need a lot of skills, and machine learning is just one of them. And data science is also not big data. So big data came from the computer science domain. So big data is actually like huge, like very huge sums of data, like very, very huge data. And you need to be able to analyze big data or make insights out of it. Doesn't necessarily mean you are a data scientist, or data science is equivalent to big data. They are actually two different things altogether. So we'll look at data science versus machine learning, um, the differences. So looking at the data, as I said earlier, the graph, sorry, data science is actually very huge. And you realize that data science is intersecting with artificial intelligence, it is intersecting with machine learning. So if you are called a data scientist, then I mean everybody is looking up to you because you are supposed to know a lot of things. I call myself a data scientist, yes, but I'll say a junior data scientist because I know that there's still a lot of things I need to know. Of course, you can't know everything, but there's so much that is expected of you as a data scientist. And data analysis is just like one aspect of it. And as a data scientist, you're expected to be able to be even build models. Like you're supposed to know something about machine learning. You're supposed to know something about artificial intelligence. Artificial intelligence is a broader aspect, and machine learning is just like a fraction or a subset of artificial intelligence. We also have deep learning. Deep learning is like goes very focused. So deep learning is also a subset of machine learning. So data science is very broad, and so you see that machine learning actually the science of getting like the machines to interpret data. So, for instance, as a statistician, maybe you collect your data, either you go on the field to take the data, or then you do some forms, you send forms around, or you do this Google forms, people fill, you get the data at the back end, then you sit down, then you do the analysis overnight or over some number of days, depending on the deadlines you have. But in this case, machine learning is where you want to train models. So instead of you, the human being, sitting down to do it, you train the models to learn the pattern. So the moment now you get the data, you just feed the data to the machine or the model, and the machine or the model is able to interpret it by itself, process it by itself, it's able to analyze it in order to solve real world problems. And so machine learning makes it like very fast, not every day doing the traditional thing, but it makes kind of like efficient interpretation and efficient insights. So machine learning has three types. We have the supervised, we have the unsupervised, and we have the reinforcement learning. So I'll talk a bit about each of them briefly. So the supervised is actually, let me go to the next. So we have the diagram so you can appreciate it very well. So we have the machine learning, we have supervised, we have the unsupervised, we have the reinforcement learning, and I'll start with the supervised. So supervised learning is actually, if you look at the name, is supervised. If you're writing an examination and the should I say, the instructors, here we have the invigilate, yes, invigilations going on. So the invigilators come around, they stand to make sure that no, you are not cheating or copying. So that's kind of like a supervised. They're actually watching you. So with this one, we have the data sets that are labeled. So we have, when you're training the model, you label the data, and so the model or the data set is able to learn. Okay, you label this maybe A. You assuming we have, let's say, five. We have five red balls, maybe two blue balls, and then you label it red, or even with the color. And so you train the model, with this data, and the model is able to learn on its own to know that, okay, this one is blue, this one is blue, this one is red, this one is red. So now when you send the data, pass the data through the model, because the data or the model has been able to learn that, okay, when it comes this way, it's blue. If it comes this way, it's red. If you pass the data to it, it's able to automatically predict that, okay, this is color blue, this is color red. So that is kind of like an overview of the supervised learning. So the data sets are actually labeled, and then you training the model, or you behind the machine, we are watching to see if the model was able to predict it well or not. And so if the model is not able to predict it well, you still train the model with more data sets so that you have like a minimum error. So when you train the model, you have the opportunity, or you have the chance to check how efficient the model is. You look at the errors that the model has made, and you can tell, okay, if the model made maybe 10% or maybe 5, then it's okay. But if it's making like 20% error or 50%, then you have to train it with more data sets. And so we have the regression as part of a supervised. We have classification. So regression is kind of like trying to predict, and this one is like deals with variables, continuous random variables. So maybe you want to predict the score of a student in class. So assuming maybe you're teaching a class and you have the details of the students' scores over a year, maybe in the university. So you use that data to train the model, and you're able to predict that, okay, since this guy or this lady had a B in intro to probability, it's possible that maybe the next semester introduction to probability number 2, you can get a B. It's either the person will get a B or not, and it's possible the person will get an A. But because of the past data we have, it's able to predict, okay, the person will get around maybe 70 to 80, or maybe will get 85. So we can use that to predict. And examples is weather forecasting, markets forecasting, estimating life expectancy, population growth prediction. So if this year the population is maybe 1K, and previous year the population was maybe just 0.5K. So you can use that data to say, okay, next year this is the population that we expect to have. However, classification is more of a yes or a no. So this is continuous random variable, but this is kind of like what's the right word to use? Should I say non-continuous? No, discrete. Yes. So this is a discrete random variable. So discrete is like a yes or a no, a yes or a no. It will rain today. It won't rain today. So you predict. It has rained. Maybe if you pick this month, it rained on these days. So you can predict, will it rain today or it won't rain today? So is this a fraud? Is this transaction a fraud, or this transaction is not a fraud? Is Is this image Emefa or is this image not Emefa? So you train the model with a set, like lots of images, and when you pass a picture, say Emefa to the model, because the model has learned the features of MFS face, how it's looking, it's able to tell that no, this picture you actually passed, if it is not MFR, it will say no, this is not MFR. So that is classification. When we move to the unsupervised learning, we have clustering, we have dimensionality reduction. So the unsupervised learning, and this one, you have not labeled your data sets. This one, you're not supervising the person. It's just like someone writing an examination, and then you just leave them, maybe 10 people writing, then you intentionally leave them to see if they'll actually copy or they won't copy, or they'll be able to um, just concentrate on what they are doing and then just write without reaching the examination or practices. So this one, you don't supervise the person. Unsupervised learning, you don't label. So you want the model to actually think for itself and be able to detect that, okay, this is red, this one is blue. This one, you don't label it for it to learn. You just label it like that for the machine, the model to just pick that, okay, looking at the data that is coming in, this is going to be red, this is going to be blue. So that's more of unsupervised learning. And an example, a practical example here I'll say is clustering. And under clustering, we have the customer segmentation, we have the targeted marketing, we have the recommender. I'll take an example on the customer segmentation. So with the customer segmentation, assuming maybe you've come up with a product, and this product is probably depending on the quality of the product, depending on the type of product, maybe it's for a certain class of people. So the customer segmentation comes in when maybe you're able to segment customers. So for instance, you sell at a shop, you're an entrepreneur, you're a businesswoman, and maybe you use data in your business to be able to help know what to sell and what not to sell. And so you have data on every transaction that is going on. And so when you have the data, you know the kind of people who come back to buy, assuming you take the names of people who buy and all that, they have special IDs. You know people who come back to buy more often. And then you know the kind of things they buy, the price range it falls between. And then maybe someone also will only go and buy, and the person will just go and buy things ranging between maybe 1 cedi and then 10 cedis. But we have this class of people, when they come to the shop, they buy things over 500 Ghana, over 1,000. And so when you have all this data, you want to know the people you have in your business. So you run the model and you're able to see that, okay, this particular um, buyer buys this kind of things. So you can label them like the gold, and then label this people silver, and then label the other people maybe another thing, because you know that, okay, then these people, they bring more profit to my company. So you want to pay attention to the things they buy and make sure you stock your business with those kind of things, because when they buy it, I mean, you make more money. I don't want to say those who are buying the cheaper items are also not important. They are, but most of your profits are coming from this segment of people. So you want to prioritize them and make sure that when they come to the shop, like, they always have those items. Those items cannot like run out. It should always be available. They should always make sure those items are there. So when they come, they can have access to it, buy it, and then you also make your profit. So this is just like a practical example. We have of the targeted marketing 2 years. That also related to the entrepreneurship. So you get to know, okay, which people your target markets are, and then you're able to know who to go to. If you are producing maybe Coca-Cola, Coca-Cola's target market is not like the elderly ones, even though maybe they want to take it for fun, to just clear their throat or something. But Coca-Cola is actually for maybe the younger ones, to be able to buy easily. Grown-up ones will actually go for the ones that are a bit healthy. So you can use this to be able to also train your models and be able to target your markets and make a lot of money through that. We also have the dimensionality reduction and all that. That's if you have like extremely big data and it has a lots of columns, it has a lots of variables, and some of them are not relevant. Maybe you want to predict A, and then it has like 35 columns. So you as a data scientist, you have to go through, see the ones that are not relevant, or the whatever you want to predict for the business question that comes in. You should be able to test all the columns and see the ones that are not really relevant in the model. When they are not relevant, you just take everything off the model and then keep the key columns that are relevant. And so you use those variables that are relevant for your predictions. So you are reducing the dimension of the data. And also we have the reinforcement learning that has to do with the same training of model. But this one, you train the machine in a way that, okay, if you get maybe you're able to predict this item correctly, you're going to get a reward for it. If you don't predict it correctly, you're going to be sanctioned. So this one is good for real-time decisions, and it can be used in the game AI field and the other fields as well. So the other ones do not come with any sanctions or reward, but the reinforcement learning comes with a reward. So even if you're working in the company and you you put in all your best, but the company or the CEOs and the supervisors, they don't really appreciate it. Whether you put in your best or not, you're just being paid. It do not really encourage you to do more. But if you put in your best and you're able to meet the target and they give you maybe the best um, employee for the quarter, you put in your best because you know that if you don't put in your best, you won't get an award, maybe you won't get promoted, maybe you'll be sanctioned for something for not meeting your target. So you put in all your effort. So this one helps with like real time decisions. So these are the um, branches or the types of machine learning: supervised, unsupervised, and reinforcement learning. And so we'll talk about like key differences between the two. I think for my presentation, I've drawn out like very clear distinctions that I would like to hammer on these two. Is this two is very confusing. People think machine learning is like data science. People think data science is machine learning, but even though it's just a thin line, one is a subset of the other. So um, they are not the same. However, there's an intersection between the two. So one is part of the other, but they are not deliberately the same. So machine learning focus on enabling machines to self-learn. So they self-learn and execute any task. But data science focus on using data and complex machine learning algorithms to help businesses analyze and understand trends. So data science will go in and use machine learning algorithms to help them analyze their business data and understand what is going on in the data. So you can't be a data scientist and have no idea about machine learning. Like starting with machine learning is actually the good point to start off with being a data scientist. So if you call yourself a data scientist and you have no idea about machine learning algorithms, then I think you have to go back and then recheck it. And machine learning is a branch of artificial intelligence. So artificial intelligence is like the bigger umbrella, and then you have machine learning being under artificial intelligence, and then you have deep learning being under machine learning. So we have lots of, I think we have the natural language processing too, we have the computer vision and all that, but our focus is on machine learning, so we'll not go deep into that. And so over here, you see machine learning is a part of data science, and it's one of the skills you need as a data scientist. So it's a skill you can't do away with. Yes. And if you have any questions, you are free to ask. Um, think our next slide will be a pop quiz. So if you have any questions, ask all the questions you want to ask. Before I drop the link into the chat, and then you take, it's not difficult, just to test whatever you have learned. And then you take the pop quiz and they will continue from there. So I have some 1 minute for questions. Any questions? Okay, I see a yes. Okay, but it's not coming.
Hello. Hello.
Hi.
Hello. Hello. Okay. Thank you. Sorry, quick. I like to, sometimes maybe when you're trying to tell somebody regards to machine learning, some people feel, with the word machine as if it's an equipment. So can you please start to break that out for mind of people so that they don't see machine learning as if a device that is
Oh,
constructed for you to now get it trained. I don't know if you get what I mean. From the
okay.
terms of like when you say mechanical machine,
Mm-hmm.
that's
Mm-hmm.
so that people don't see it that way as is this thing a technical, is a equipment, as
Okay.
in, yeah. Thank you so much.
You're welcome. So yes, as you rightly said, because machine from the mechanical point of view, that has to be with something you can touch, like hard something. So people would think it's actually a machine, but machine learning is actually it's kind of like building models. Most of them you have to code them. So I'll say it's more of the coding. You code them and then you test it on your machine. When I say machine, you test it on your computer. Let me use the computer, or you test it in your Python, or maybe your R, or yes, you test it in there to make sure that it's working. So when you test your code and it's working, then maybe you want to move it to a deployment stage. So you don't want it to stay in your computer without doing nothing. So you want to move it into your deployment stage. That is where maybe you have something physical coming in. Some will not be physical. It will still be on your computer or your phone or something. But maybe the physical machine comes in, maybe in the field of robotics, where you have to, you've already done the coding in your Python, in your R, you've deployed it and it's working. So now you want to test it on a robot. Then the robots, the mechanical guys will just put the shape and everything together, and then they embed the code in it. I'm sure, I don't know how, that is not my fault. I don't know how they do it, but maybe you have some circuits coming in, and then they test it. So if I write the code that, okay, when you see someone maybe stand, so they want to test it using the robots. So machine learning is not actually just robots when you have to see something, but you can write a code and then you can test it maybe on a phone. You can test it in the web. So the physical machine, as he rightly said, comes in when um, it goes into the robotics aspect of it. That's from my point of view. I hope this answers the question.
Yeah. Thank you. Thank you.
You're welcome. What we have next is data science examples. I think Fortune made mention of a question. I believe it's been answered. The how did say what branches of math do we need to know? So the statistics, linear algebra, probability from Inuela, the linear algebra, calculus, statistics. Yes. So these are all things you need to know, especially with the statistics, probability, bits of calculus, and a bit of linear algebra. If you want to be a machine learning engineer, then that one you really have to, because you do the logic. behind the thing and all that. So now you really have to focus on the linear algebra and the calculus and all that. But if you want to be a data scientist, you just need like a bit of each, and then you just put it together. So that's right. Thank you for the contributions. Okay. So we want to have some practical data examples. So one example where data science is applied is on website recommendations. And this method is used by internet companies. Example, yeah, Amazon, Twitter, Netflix. And the picture there is showing you an example of it. So you realize that maybe you buy from Amazon. I'm using Amazon for an example. You always go online, and assuming you're a fresh mom, so you go online to Amazon, and then maybe you search for baby stuff, babies wear, feeding bottles, pampers, and all that, and you buy frequently from Amazon. So Amazon is able to, I think they have this ML embedded at the back of their website, so they're able to know that okay, when this particular person comes to the site, this particular person normally search for baby stuff. So the next time you open or you want to go to Amazon to buy, they've already realized that okay, you want to buy, you'd be interested in buying baby stuff. So before you even open, maybe you don't even plan of buying uh, maybe a new product for babies. You don't have plans, but because you've opened it, then they give you that pop-up that is in relation to babies. Be like, oh, okay, let me give this a try. I mean, I think I'll use it. My baby will need it. So they use this to help them to recommend products you might be interested in buying. So, for instance, Netflix is more of movies. Movies. You have a particular type of movie you like searching or watching over there, and so the next time you open, they're going to recommend similar ones you'd be really interested. So if we all have Netflix and we go to Netflix individually, what they'll recommend to me is different from what they'll recommend to say Fortune. It'll be different from what they'll recommend to every individual. So it's kind of like a specialization stuff so that you can buy. And this also increases their sales because maybe you don't plan on buying something, but because they recommended it to you and it looks like appetizing or it looks nice, you end up buying it because you just love that kind of thing. And so that also increases their sales and then they make more profit from it. So this is one of the practical examples you can use data science for, or you can apply data science. And also recommended these recommendations, as I said earlier, is based on your subscribers per search. So whatever you search, that is what they use, to be able to tell what you might want to need next. I'll use also Google. Maybe you are a grad student or you're a student and you want to learn data science and analytics. So maybe you want to go to school. So you go into your Google search and then you type, okay, MSc data science, blah, 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 search. You've been doing that for some time and it's able to pick up, okay, this user likes things. So the next time you open it, you just type MSc and then they are going to continue it for you with data science or with machine learning. Like they've already predicted what you are coming to type. So you just have to go down and then click on it because that is exactly what you want. So this is how the data science is, um, used, and it makes things very efficient. Maybe you have something you want to buy, you've forgotten the name. When they recommend it, but yeah, this is what I wanted to buy. So you just click on it and then you just place the order. That's one example. And an second example would be a virtual assistant and health robots. So these are AI-powered smartphones apps, which are mostly chatbots. So you see that iPhone has currently added that to it. They've even come up with this smartwatch that is linked directly to your phone. So it's able to tell your heartbeats. It's able to tell the number of steps, as you are walking. It's able to count it. And you ask them, how is this how did they do this? But this is the idea behind it. So this, you're able to detect your heartbeats, your the number of steps a day and all that. And also sometimes when you visit websites, if you stay, I'm sure they've programmed it in the way that if you stay on the website for maybe more than 5 minutes, maybe more than 2 minutes, you see an automatic pop-up chat box that asks you, okay, I'm so and so, how may I help you? Do you need any assistance? Do you need anything? So these are AI or data science features they've added to the platform. So if you are interested in something they ask and you enter, okay, I'm looking for this and this, and you enter, it is going to give you a feedback, and that feedback will be exactly what you need. So this actually helps, and these are like virtual assistants and then health robots that are there to help you in any way. So that's also a practical example of data science. Our third example, this is text and advanced image recognition. So Facebook uses that. Image recognition may be found on Facebook, Instagram, Twitter, blah, blah, blah. And then the virtual assistants like Siri and Google assistants and all. So for instance, you have a Facebook account and then you post, you update your profile. Anytime you post, they have that feature at the back end. Anytime you post, they're able to they know that okay, this is the face you have on your profile. When you post something, that is your face. It's like it's learning everything, the pixels and everything, it's picking it up. So you do that for a number of times. You've used Pay for maybe 30, 1 year, 2 years. So now it has learned the features of your face. It has learned everything about your face. So if a friend, maybe you went to a tech program with um, you went for a tech program, let's put it that way, and then you met new techies, and then you took some pictures and all that network and everything, and then the person gets home, and then of course you want to, especially on LinkedIn, you want to show that okay, I went for this program, and the person posts you. It's a group picture like what we see here. The person posted a group picture which you happen to be part. So Facebook is able to see that okay, this person here is has the same features of Gary. So in this picture we have Gary. So it will send you a notification that someone has posted a picture and they think you are part of it, like you are part of that picture. So you see that here it's added a photo and you might be in. So it will give you that notification because they've picked the pixels and they've seen that, oh, you're the one. It actually matches. So you go and then you realize that, oh, truly, that was the right prediction. You were actually part of that picture. So this is one of the data science examples we have, advanced image recognitions. So I want to talk about the skill sets of data scientists. So to be a data scientist, you will need to be able to gather, clean, analyze the data, then present your findings. That's the most important thing because that is what the businesses need. They want you to advise them, what do I do next? What direction should I go? And they are all looking up to you. So if you give them wrong insights, they apply it and then they are making losses, then it looks like you're going to be fired soon. So at the end of the day, the insights are the important thing. That's like the end goal. And you'll need both your technical and soft skills. So with the technical skills, you need programming skills. So if you have computer science background, that's bingo. You need SQL. SQL is also kind of like computer, it's also programming. That's also cool. You need statistics, probability, and data analytics. Yes, so I think the lady that asked which part of math you need statistics, you need probability, you need data analytics, and then you need to have the skill of visualizing your data. So the thing is that the stakeholders, they don't care about the codes you've written. They actually don't care. They just want you to make meaning and tell them which directions to go. And so the best way normally is to present a very simple visualization, not any complicated visualization that when they are looking at they're confused. Something very simple to say, okay, this went up, this is going down, this is a trend, this is what we should do. So this is very key when um, you are presenting the insights to the stakeholders. You need business strategy. That's kind of like the domain knowledge. So if you happen to be in the finance domain, then you can advise them well. If you happen to be in the agriculture, you can advise them well. If you happen to be in the health sector, you advise them well. If you happen to be in accounting, you advise them. And then you need the ML and AI skills. So that's the skills. And in as much as we want to know the technical skills, we have to invest time in growing our soft skills too. Because assuming you do all the coding correct, the insights, effects, you build your dashboard, and then you are doing a presentation to the stakeholders, and you're not able to communicate the insights well, it won't go well. Maybe they will not even believe what you are saying. They will not even take it. So you really need to have a very good communication skills to catch their attention, to convince them that this is what the data is saying, and this is what we have to do to make sure that we'll reach our target. And you need to be an analytical thinker. This is also key, and this will grow with time because sometimes um, they will give you the business question. So you shouldn't just focus on how to use the the softwares like the R or Python, depending on where you find yourself, the SQL, the Excel, the Power BI or Tableau. It's not just how to use them, but how you can make insights, with those tools. So you need to be an analytical thinker. They will come and just give you the question. Okay, we want this. Track the performance of this student. Track the performance of this employee. Um, yes, that's what will just come. That's the task that will come. And so when the task comes, and then you have the available data, you have to know, okay, what software or what tool will be best for analyzing this data, or if the task came with a required or a recommended tool to use, then you have no option. But if it becomes open-ended, you want to choose which of these tools will best solve this problem. How do I go about it? What should I do? Which models do I need to load into the Python or the R? What libraries do I need? How do I write the code to answer this particular question or to get that particular data they are looking for. So you need to be an analytical thinker, which me myself I'm still building because in the team that I work with, when the tasks come, you have this person who it's not automatic, you build it. He's able to code it and like that is exactly what they need. But sometimes for me, when I get the code online or he writes the code, I'm able to understand what the code is doing. When I read the code, I understand, okay, this is what it's doing, this is what it's doing. So I understand the output. But how do you put those codes together? That's where the analytical thinking comes in, like the logic. Do I put this before the other? Must this come first? So this is something you build, the analytical thinking. The more you work on project, the more you work on tasks, then you know that, okay, I need to do this, write this line of code before I write this line of code, or I need to click on this on Excel before I click on this on Excel. And you also need to have a storytelling skill. You don't want to be boring when presenting your insights. You need to start with something that will catch everybody's attention. Everybody's like listening to you. So the moment you start presenting and it's like you're just like everybody is not even listening to you, even though you've done the work, you have the insights, but you didn't present it well. You didn't start off with something that will catch people's attention. But people are sitting there listening to you, but their mind is somewhere. They're not paying attention. So you need to have something like a storytelling skill that will attract people to listen to you or even to read. For instance, you post something on LinkedIn and the person read the first two lines and this is not something I'll be interested in, I'll not read it. But if you have a nice story, you read the first two lines, oh, this is something that will be very interesting. I want to read more. So you need to have this skill. And you need to be a continuous learner because this tech field, it keeps evolving. Every other, should I say, domain or field or career evolves, yes. There are no two ways about. But the tech field evolves like very fast. Today, ChatGPT. Tomorrow, I'm sure someone is writing a code that is going to be more than ChatGPT. Today, this software. Tomorrow, this. Before you realize, within a year, they've released so many. Today, they say Excel. Tomorrow, Power BI. The next minute is it Asia, the next minute AWS, the next so like you need to always not to like you can't know everything, yes, but just have an idea about what each tool does and what it's doing. Just have an idea, just keep up with tech the tech trends. So you will not be a techie, you go for a program or you meet someone and the person mentions Tableau and you're like, what is Tableau? Or the person mentions Asia, or like, what is Asia? So just keep up with the tech trend. Just know what's going on, and you can't learn everything. Specialize. Choose one. Be perfect at one, and then specialize. But if you happen to be already working, then it makes it easy for you because you know this company uses maybe Power BI, so focus on Power BI, and then you kill it. But if you're still learning, before you land a job, then you have to learn a bit of everything to know. Then now, out of that, you choose the one that you are really, really comfortable, and then you master it. So maybe you land that job that maybe that is what they use, or that is not what they use. Then now you have to learn and then to add to the knowledge. So be a continuous learner, and then pay attention to detail. This is very key because if you miss something, this is an insight you're giving to a whole company. I believe Coca-Cola have their insight team, they have their data. Sambe has their data team. And a whole Coca-Cola, if the data team gives them wrong insight because they fail to pay attention to a particular detail and then they give a wrong insight that is going to ruin a lot of things and making them lose a lot of money. I don't think they want to maintain you. That's why most time they have a team. You work as a team, you double check, you cross your T, you dot your I's before you go out there and then present your insight. So if you're not one who pays attention to detail, you can just overlook certain things and it will to ruin your career, like to ruin your career. So you build it with time and then you need to work in a team. I think I mentioned it earlier. So currently I work in a team and you learn from each other. I learn from them. They also learn from me. And you're able to work in a team because one person can overlook something and you end up giving a wrong impression. So when you work in a team, if all of you arrive at the same thing, then you are solid that this is what it is. But if you're unable to work with team, everybody's going direction A, you're saying direction B, and it's like conflict. They don't really know how to work in a team. Everybody is saying A, but you are so sure that it's B. It is B I'm going to send. Meanwhile, all your colleagues are saying it is A. So why not check your code, check what you've done, and see if truly you made a mistake somewhere that you need to change, or if truly yours is correct and theirs are actually wrong. Find a way to, um, I won't say convince them, but show them that okay, this is the step I did, and I think it's correct. So just know how to work in a team. Else, there's going to be conflict of interest. And end of the day, if the team does not have like that um, how do I put it, that serene environment to work, Like you are drawing the company down. So just know how to work in a team. Next, we'll talk about the data. I think it's the final one we have for today, data science pipeline. So the data science pipeline, it refers to the process and tools used to gather and draw data from multiple sources, and then you analyze it. So first you get your data, you load your data into your computer, of course, or your laptop, because that's what you use for analyzing your data. You look at your data, what you need to do, preparing it, you analyze it, and then you present the insights. So it's like, where do you start from and where do you get? So the reason why we do all this is because of the insights, the policy decisions. That's the focus. But where do we start from? You start from the data collection. So you get your data. Of course, some data are very, very messy in real life. Even you send a Google form, enter your name, someone will enter all caps, someone will enter um, the caps for the first letter, and then small caps for the others. Someone will enter all small caps. Like so when you get your forms back in the back end, like the Excel, you now have to go through the data and make sure that they all have the same format. If it's all caps, it's all caps. If it is lower key, it should all be lower key. If the first one should be an upper key and the rest should be lower key, every data should be like that. So that's why you do the cleaning, data cleaning and all that. Someone will enter Emefa, for instance, and then press like two space bar before entering the GIA. Somebody will just combine it together without space. So you'll be surprised that you send a simple Google form, and when it comes at the Excel, you have to clean it. So you need to clean and process it before you start your exploration and then visualization. That before you even go into your data analysis. Because if you don't clean your data, then you're going to make a wrong insights and you're going to give a wrong data insight over here and give wrong policy decisions. So you have to take your data, clean it, pre-process it, explore, want to understand how your data is, want to understand the columns we have, the number of data, the rows and all that, visualize it. Is it a normal distributed data? Is it left skewed? Is it right skewed? Can you do something about it? Do I have to standardize it? Do I have to make it look normal? You look at it, and that will give you insight on what actually to do with the data, and that's the data analysis. And when you are done, you have your data. So this in reality, it looks like a linear, but it's never a linear process because sometimes you do the data cleaning, you come and be doing the visualization, and you realize that one is in caps, one is not in caps, then it makes the visualization bad. So now you have to come back into the data query cleaning side, whether you're using Excel, and then change it, format it so that it will reflect in the visualization. Then it looks nice. So sometimes it can be data analysis. You can even get to the data insights and then you realize that something is not going. You have to go back and then take more data, or you have to go back, then clean it. You have to go back and then do exploration, or you get to data analysis, something is not going well. You come back to the data to see, why is this causing this? You are expecting something, you're not getting it. There's something wrong somewhere. So it's not a linear process. It's like you can go back, come. It's just like the design thinking process. It's not linear. You can go back, come back anytime to make sure that the insights are like very good. So we'll take this one by one, data cleaning, data collection, blah, blah, blah. We'll pick each um, point one by one on the data science pipeline and we'll delve further into it. So data collection is the process of gathering data for use in business decision making, strategic planning, research, and any other purposes intended for it. So we have two major types of data collection method. We have the primary and we have the secondary. So the primary is when the data is not already in existence. So you want to go out there and pick that data for yourself, depending on what you want to use it for. So for instance, survey, now you can even do a survey on the Google Forms. then we get it at the back end. And then you ask all your questions, you fill the survey, we get it. Or maybe in those days and years ago, you print it on paper and then you send it out, you share to people you meet, depending on how you got your sample size and the caliber of people you want, um, and how you got those particular people, because it needs to be um, a random sample. You don't want it to be biased. So depending on how you did everything, you go out there, you print out the forms, you share to people, they fill it. Then you now come back and enter. That's the data entry. You come in, you enter the data into the computer before you analyze it. But now Google Forms has made it easy. And even I think WhatsApp, yes, WhatsApp has now even added the polls. So you see down here, we have the polls. So WhatsApp even has the polls that if you want feedback from the people on the WhatsApp platform, you just do the poll. Everybody on the platform will just give their answer, and then straight away you know that okay, we are going for this or not. Okay, from the feedback, we are not going for it, or from the big one, yeah, we are going for it. So that one, at that point, the data was not really in existence. But for instance, maybe you want to hold a tech program, or you want to have some small get together, and you want to know if this would be really of interest to the people on the platform. So you do a short poll. Do you want to have this get together or not? So the feedback will inform whoever is organizing that program that hey, they are interested in it. Let's go ahead. We'll make some losses. We'll have the numbers coming, and then this is something they want, and they'll be happy to enjoy whatever program you're organizing. So polls are just one way of taking data. Interview. So you see these journalists, they want data. They want to know how things are going. They go to the markets, they interview people, they take their response, they record it, and then it helps them with whatever analysis they are doing. We also have focus groups. So focus groups is like, for instance, you 3 or 4 people come together, sit down, round table, you ask them questions, you listen to how each person is going to answer it, then you take the relevant information you need, depending on what you are going to use it for, then you go and use it for your insights. And then we also have statistical methods. I already mentioned the pool. So statistical methods like this, what example am I going to use? So I remember during my undergrad, I did something relating to how do you call it, random generation of this distribution stuff. So because my data, how the way I wanted it, it's not something I have to go and collect. It needs to be, I think they called it bootstrapping. So I did it in R then because it was required. So you use that R software to randomize, to give you some random numbers for the distribution you want. And then you use that distribution, to that random numbers generated from that distribution to make your insights or to build your models or whatever. So that one, for instance, can automatically give you the data to work with. And then we have the secondary data. So the secondary data is like it's already in existence. So you just want to just go grab it. So for instance, sales reports. So for instance, you want to make analysis of what company should I use? For instance, let's say Melcom. So Melcom already have this. When you buy, you get to the sales points, they enter your details, they scan the barcode, so automatically everything is being picked into their system. They know who, the time, what you bought, what money you paid with, the balance they gave you. You have everything in the data at the back end. So if you want to have a sales report, the company wants to say, okay, you want to analyze our sales. You want to know whether we made more profits this year um, in comparison to last year, year-on-year profits or maybe month-on-month profits. You want to see if this month, you've made more profit as compared to last month, then they'll go to the back end, and most of them come in Excel. They'll pull the data, then they analyze it straight. So this one is not like they are going to the field to go and analyze it, they like go and collect the data. They already have it. So it's a secondary data that they are keeping. They have it in their big database, either on their laptop in Excel. But most of these big one, they can't go into Excel. So they need to keep it in the cloud. So they go there, they pull the data they want for that particular year or for that particular month, and then they do the analysis on it. The same with financial reports. So you do Momo, you buy credit on your phone Momo, or you transfer money from your bank to your Momo account, you transfer money from your Momo account to your bank, you make a purchase, you buy lights on Momo, you do a lot of things on Momo. So they have the database already there. So you want to see, you want to see how we are doing, you want to see if people are using the Momo platform, kind of like the app experience. Yes, in app experience. So you'll see we have a lot of people visiting the Momo platform, want to just make insight to know whether they are getting more customers or they are losing customers, people using their app and all that. So that one is already there. Then they'll go and download it, or that is where the queries comes in. They select blah 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 from this table, inner join, outer join, limits to 5, whatever, top 10, whatever. Then you now get the data on your local machine, or you can even work for the data directly in the cloud to make insights. And also we have the internet. So everything we put there, we put our pictures, we put our achievements, we put everything on internet. So when they want data, that's what they call it the data scrapping. Is it scrapping? I think. Yes. So data scrapping, you go there, they have a way of doing it. You download everything. You can even go to Amazon. They have a way you download the data, the items they have and their prices. Then you go to maybe Melcom, you download the items and their prices. You go to several online platforms, the things they sell, and then now you want to come and compare and see the average price. Maybe you are starting a business, you want to see how to price your items. So you compare the prices from other people and then other companies, your competitors. Then you be able to give the average, or a little above the lowest, or a little above the highest. I don't know how you want to do it, but these are all data collection processes. And then the data cleaning and processing. So most of this data you download from online, or you get from either um, how do you call it, the secondary or the primary. It comes with errors. So sometimes maybe when you go and then you fill forms, maybe paper, you wrote it all, but when you go home and you're trying to type it into your Excel, you're not seeing some particular place, or maybe you were tired and you didn't write it well. So it's an error. So when you enter everything into your machine, you now want to go through, you remove correct, maybe corrupted data, maybe incomplete. So for instance, they ask you when is your when is your day born, and then they leave it open. So ideally, they're supposed to, if you want to reduce the number of errors you have in data, you have to do something we call the data validation. So you make sure that you restrict the person, so that the person will not add something that is not relevant. So assuming enter your how do you call it, phone number, then you are writing letters. So you're supposed to do it in a way that the moment the person enters a letter, it will give an error, wrong, whatever entered. Enter the correct data. Maybe when you enter the 024, it will pick it. So when you do those validation process, it reduces the errors that you get. So if maybe you want enter your email, and then the person is in a hurry, so mistakenly he left out the at. You're supposed to add that restriction that if the email is not coming with the at, that's an invalid email. So the error. So without correcting it, you can't submit it. So this helps with the data cleaning. But if you leave most of your leave your questions open-ended. Then they'll ask you, when is your day born? Someone will write, for instance, me, I'm a Tuesday born. Then I'll write capital Tuesday. Then someone is a Monday born. Then the person will write MON dots. Then someone is a Wednesday born. Then that person will write WEDS. So one of the day, when you receive the data in the back end, it's not having the same format. You have to correct it. Make sure that if it is abbreviations, it's abbreviations. If it is full, it is full. No inconsistencies. So you check everything. Incomplete data, sometimes duplicates, especially when you combine multiple data sets. Sometimes you realize that there are duplicates. So you have to check if there's duplicates, remove all the duplicates. So you work with the correct data. And then the data processing comes in when you collect it and you are translating it into a usable information. So data cleaning, then data processing. You check for duplicates, the data that are not relevant, take it off. The ones that are not correct, just take it out. If you have, if there are any structural errors, you fix it. If there's missing data, you have ways you can replace that. So if missing and is categorical, you can't do anything about it. But if it is quantitative, then you can either replace with a mean or with a mode or however, or prediction, regression, however it is. You check for outliers, you do the standardization, the normalization, and all that. So these are ways to make sure that when you invest time in the data inclusion process, the analysis becomes easy. It becomes very, very easy for you. So you also have to check the data types. So for instance, the data comes in and it's seeing it as a phone number, it's seeing it as text, or it's seeing it as a number. If you don't change the number to text, it's going to see the phone number as a number and it's going to perform calculations on it. It will give you the minimum, it will give you the maximum, it will give you the average. But the phone number is not supposed to be used for calculation. So you have to change the type to a text so that it doesn't perform any mathematical calculations on it. Because the phone number is not something we are supposed to use for. So all these things helps. Changing the data type to suit what you want, then it makes the analyzing easy. Exploring and visualization. So this is where you now want to see, okay, I've done my data cleaning, everything looks good, perfect. You transformed it, now you load it into your tool you are using. Now you want to be able to identify trends. So the advisable thing we do is that you want to see the distribution of each column or each variable, just to see the distribution. Do we have an increasing trend? You have a decreasing trend. You want to see like what's going on generally before you come and fix the particular task or business question at hand. You want to visualize your data. You want to have an idea what's your data and how your data is looking like. That will inform you on how to go about applying which technique to answer the question. So for instance, if you have a data, you check the distribution of the data and the data is having like a lot of outliers, then you know that okay, this data has a lot of outliers. How do I fix the outliers? Do I take it off? Or if I take it off, is it going to affect the insights? What do I do? Or you check it and um, there's no distribution, it's just scattered around. So all these things helps to make your analysis. And so it's advisable that when you explore the data, you visualize it, you plot charts, to see how the distribution is, the percentage, right? And depending on what you want to do, and then the particular chart you use for it, that will make the visualization more appealing and more, um, and being able to communicate the insights quickly. So, for instance, let's assume you have this pie chart. This pie chart is having like one, two, three, four, five, six, seven, about eight different categories. It's not advisable to use a pie chart. It's supposed to use like a bar histogram or a bar chart. If you have at most three, then you can use a pie chart or a donut chart But this one, it's make it difficult for people to understand this thing right here. So instead of using a pie chart, you're supposed to use like a histogram or a bar chart. Then to make it nice, you can even do maybe the top three, then you highlight the first one maybe in a particular color, then the rest you leave it uh, maybe in ash or something, because that's not what the focus is. So that is it for the visualization. And then data analysis. Now we've done all the visualization, we've seen how the thing is looking like, and now you come to the proper data analysis. This is where you apply the machine learning if you want to. So this is the process of systematically applying statistical or logical techniques to describe and illustrate and then evaluate your data. So we actually have four types of data. We have the descriptives, we have the diagnostic, we have the predictive and prescriptive. So to break this down for you to understand, um, descriptive is like trying to find a summary. So you want to find a summary, you want to find the maximum, the minimum, the mode. It gives you an idea, describe your data. That's the first thing you do. So it can help you. And then we have the diagnostics. So the same way I'll relate this to going to the hospital. So the same way you go to the hospital, you're not feeling well. The doctor asks you, what's wrong? My head, I can't sleep. Then the doctor writes it down. So that's more like the descriptive. Now, you want to diagnose why is the head aching? Why is she not able to sleep? Why is this happening? So you go and do your labs. Then you go and do the labs and then you bring to the doctor. Oh, so this is what is happening. So the same thing with the data. You do your descriptive. You want to know what is happening, what is happening. So you take the diagnostics analysis. Why is this reducing? Why did sales reduce this month? What did we do? Why did we have reduced number of people coming to buy? Is there something we are not doing well? Do we need to do something? So you find that okay, maybe we didn't stock our staff on time. So people came and maybe they did not buy and they left. They went to different shops to buy. So that is why the sales actually reduced. And we'll say, oh, okay. But if then we know, okay, next time make sure that the stocking time comes fast. You don't wait for the items to finish before you restock. Like whilst it's getting finished, restock so that people. So you want to know why, what is happening. Then the predictive analysis. Predictive is where I'll say the machine learning comes in because this is where the modeling, most of the modeling comes in. You want to predict. Predictive is actually okay. We lost money this month. What can we do so that next month we can have our sales up again? If we predict per the data we have, we are not going to meet the targets. So what can we do to help so that we have our sales ongoing, increase in sales and everything? So this is where you model, okay, you predict if it is regression. Okay, you made 1,000 this month. You are predicting for next month you are making 800, but the target is 1,000. What should we do? So that is where the machine learning comes in. You build all the necessary models that you need, and then you're able to predict just to inform the company that this month we are expecting this, but we can still do something about it so that we can meet our targets. And the final is prescriptive. So if I want to relate this to the hospital case I was bringing, so you realize that now a lot of companies have added this computer blah 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 management system that they have your history. So anytime you come today, my head, they'll record it. You come tomorrow, my stomach. They have all your records. So it helps the doctors. When you come again, you say your leg. They will go and check your historical data and see. Today you said your head, tomorrow your leg. Or if maybe you came again with your head. The last time you came head, the last two times head, this one too head. I think we have to do a scan to see what is actually happening in the head. That you always come with head issues. So this is predicting. So they can know that the next time you come with the head issue again. So we need to be proactive. Let's try and dig down and see what's happening. Maybe do a scan, do everything, then so that you won't come back with a head issue again. And then predictive. sorry, prescriptive. That's why you prescribe. So the hospital case, they see, oh, they do the labs, they check your medical history, they can now prescribe your medicine. Oh, take this medicine. I've written this medicine, go to the drugstore and take it, you'll be fine. So the same thing with the business case. Oh, this is what you've done, this is what we've seen, we've realized that you want to make sales. So let's do this, let's do that, then we'll meet our targets. So that's the whole data analysis process. There are four types. Sometimes you don't use all the four, depending on the business question. But the descriptive is compulsory. I think the more of the like diagnostic is also compulsory because you want to know why. Or sometimes if um, the task comes and they are like they want to know why this is happening, then you focus on just the diagnostic. So it depends on the task that comes. Then you know which of the analysis to do. Our final one for today, our data insights and policy decisions. So this is actually the end product. This is what we need. That is why we are going through this long process. This is what we want to find out from the data. Some years ago, we didn't really value data, especially in Africa. And we are beginning to appreciate that we can't do without data because if you're a company and you've not incorporated data into it, it'd be like you're doing things by intones. Like you are just doing things. You don't even know how you are doing. You don't know how you are performing. If you compare yourself to someone who is using data for their analytics, they'll be doing way better because they won't wait for the thing to happen before they'll find out how to solve it. They see the losses coming from far, so they immediately take a real-time decision to solve that problem so that if the losses turns into profit. But if you're not using data, you see there for the losses to come and you're not thinking, what should I do? You've wasted time, you've wasted money. So the data gathering and the data analyzing and everything is the insights that rewards. When we, the data analyst or the data scientist or the machine learning engineer, give all the insights, but mostly the data scientists give the insights. Then you're able to know which action to go. Should we go left? Do we go right? No, let's this product is not selling. It's not giving us profits. Let's just stop stocking these products. Then we can make more profit. So through the interpretation of these patterns, organization transform insight into forecasting customer needs and therefore promote more effective decision making. So I think this brings our presentation to an end.